All right, so in this video we're going to talk about condensing logarithms. It's another property of logarithms that we can use. Rather than having multiple logarithms to solve individual pieces, it might be better to combine all the logarithms together to have a more unified picture or to solve or evaluate a logarithm. So on number 13, notice how it's log 3 minus log 8. The subtraction sign is my biggest clue, meaning if I condense these two, it would be log 3 divided by 8. So log, again, implied base 10, even though it's not written, of 3/8. Okay, so whenever it's subtraction, I take the two numbers I'm taking a logarithm of and divide them, whatever it happens to be. Here on number 14, this is a really good one. Again, let's change our perspective here. We could write this like this. So it's all being divided by 3. Isn't it the same if I wrote it as 1/3 times log base 6? Yes, it is, because 1/3 times it is like dividing by 3. If I do that, then I can move this 1/3 to the top, which would be log base 6 to the 1/3 power. And again, the point of that is we remember 1/3 actually means the cube root of 6. So log cube root of 6. All right? So that one is a little bit trickier because you had to, dividing by 3 is the same as multiplying by 1/3. You can move the exponent from the front of the logarithm to the top of the number, and then remembering that 1/3 power really means the cube root of 6. Okay, next we have the 4 goes up on top because it's in front of the logarithm. So it'd be log base 3 to the 4th minus log 8 to the 4th. Okay, subtraction is my clue that I actually need to divide these two. So it's 3 to the 4th divided by 8 to the 4th. And you'll notice that the exponents are the same. So let's see, that's 3 to the 4th, 8 to the 4th. So you can actually make it like this. So log and then 3/8 all to the 4th power. You can write it like that. Because both terms had a 4th power, you can just put it in parentheses and put the 4 on the outside. If you left it like this, it's not wrong. It's just more complete to write it like the way we did it there. So number 16, notice how it's all being added together. My clue is addition, so I'm going to multiply everything together. So it's going to be log 2 times 11 times 7. You could leave it like that, or you can actually multiply all these terms together. So 2 times 11 is 22. 22 times 7 is going to be 154. So you can actually write log 154. But again, if you left it as 2 times 11 times 7, you're not wrong. It's just more complete the way there. All right, so here I have log 7 minus 2 log 12. Let's go ahead and move that 2 from up here, from in front to the top. So it's log 7 minus log 12 squared. And then subtraction is my clue, so I write this, log, and then I would do 7 divided by 12 squared. And notice how, again, the squared term is only on 12, not on 7, so I don't need to pull it out. I can leave it just like that. And if you really wanted to write 12 squared, you can write 144. That's okay too. All right, so this one, again, a touch trickier. So notice how it's 2 log 7, then divided by 3. What I would do here is move the 2 up to the top, so it would be log 7 squared all over 3. Then you can move, so remember the 3 on the bottom means I can actually multiply by 1/3. So 1/3 log 7 squared. And then you can move that 1/3 up to the top. So 1/3 times 2 is 2/3. And again, the reason I do that, the separate pieces, is because you could do it all at once. So like you could multiply by 2/3 and move the 2/3 up on top. I guess either way is fine. And remember, so if my exponent is divided by 3, That means I could write cube root radical 7, but all of that is squared because the 2 power up there. So now that one was a little bit trickier, but essentially that is how we condense a logarithm. That is how we condense a logarithm.